All right, so welcome back, everyone. Third lecture being recorded and uploaded today. This is going to be on the fill and sediment control requirements for the course project for BSU's MIET 312 surface mining class. This is going to be a really short lecture. It's only about 5 slides. So let's jump right into that, okay? Previously, we calculated the required fill volume, and it was right at 1.75 million loose cubic yards. Okay, so remember that was from taking all of the overburden that we have to remove and then determining how much bench storage area we had and then how much was left over, right? And so because this was, part of this was previously mined, this is not a very large volume, of waste rock that we have to deal with. So what I did was I came to the head of Isaac's Holler, and I just roughed in a valley fill here, sort of expanding, towards the top, where it widens out into its maximum width here at the crest, right in the head of the hollers here. So I roughed this in, and then I looked at the area of it and looked at the overburden contours underlying it and came up with a rough estimate. And it turns out this is even a little bit oversized, where this is capable of holding actually close to 3 million, I believe, loose cubic yards. But I didn't really want to have to redraw it or anything. Let's turn on the laser pointer here to sort of point out a couple of things. And that is, the required fill volume is relatively small. You can consider other options such as side hill fills. Do keep in mind you have the road going right through here. So you may want to move that out of the way or something too. I didn't. I just drew it right in here like this. There even may be, storage options for putting some of this up here on the low gap as well, and that sort of thing. So there are other options than what I'm showing you, is what I'm trying to tell you. And you're free to use those, in the project, in the report, as long as you just basically justify where you're putting it and what size it is, right? So moving on to sediment control, the first thing we need to do is calculate the disturbed area of the watershed, right? And so we're only doing this for one watershed for the project. If this was in real life, you would obviously have sediment controls in each of the individual watersheds, okay? But I only want you to show me that you can, do the calculation one time, and here we go. So what I did was I cut off my sort of contour hatch and resaved the file as another file name so that I didn't, lose what I had. But I wanted to cut it off, and I cut it off right on this point, right here, on this point as well, and then brought it across the front. So I'm not including the backside of this ridge here, or anything over in this area, or anything on the backside of the slow gap, right? Those would all be separate structures because of the watershed. So I then added up the areas of these hatches using AutoCAD's properties. I just looked at it that way. And what I came up with, including the area of the fill, I have approximately 54 disturbed acres. Okay. So if we multiply that by 0.125 acre feet per disturbed acre, we get 6.75 acre feet. Now, acre feet are, is a measurement of volume. Okay, so, and it's usually used for reservoirs, lakes, that sort of thing. And so I'm converting by using 43,560 square feet per acre. I'm converting this into cubic feet, which for some reason I did twice. But it doesn't matter. There's, almost 300,000 cubic feet of material here. And when we take into account that I sized, my pond to be 100 feet by 200 feet, I just made it a rectangle. That's 20,000 square feet of area, and so that means that my design depth is 14.7 feet in this case. Um, just kind of simple calculations, to design the required size, and this is just sort of the a rough design, right? This does not include the slope of the sides of the pond, anything like that, or if there's any barriers within the pond to help sediment filter out, because it helps that the pond is relatively long, to increase settlement time, right? So this is what I've done for this portion of the project. And so that looks something like this. I just roughed in a 100 by 200 foot rectangle, put it at the base of the fill, right? At the head of the watershed in this case. So we're right here. And, one last thing I would like to remind you of, and this is not necessarily required, this is not required for the project, but you will also have to have diversion ditches, to divert water to the pond, right? You're going to have most likely groin ditches on the sides of the fill. They'll also have, diversion ditches from both sides of the mining here to ensure that water that falls in this area and comes, gathers sediment from the disturbed soil, that it's taken to here, so that sediment is processed prior to being released into Isaac's Run. And so with that, I'm going to close it out. This is basically, what I'm expecting for the course project in the technical report. So not too deep, not too terribly detailed. Okay, it's just think of this as a pre-feasibility study. So we're working on, concepts and skills that will be required in the senior design course, real life, stuff like that. Okay, and so with that, I'm going to get this up on the web as fast as I can, and we'll see you next time.